Today we are doing section 7.2. We are going to identify similar polygons. In order to do that, we have to be able to use proportions, which is why that was covered in 7.1. Since we did that worksheet, we will skip through some of the warm-ups. We're going to do the simplifying ones because that was not on our worksheet. So we are going to do 1, 2, and 3. In order to simplify ratios, we first need to have the same, anybody remember what needs to be the same? Units, the same units, and then we are going to simplify it if possible. Number 1, do we have the same units? Yes, they're both in inches. Both of those can be divided by what? 2. So it would reduce to be what? 3 inches to 14 inches. Remember, if the problem starts off written with a colon, we like our answer to be written the same way. If the problem were to start off being a fraction, we like our answer to be written the same way. On number 2, do we have the same units? No, we've got different units, feet and yards. It's going to be easiest to turn yards into feet. So the 2 feet will stay the same. How many yards are in 1 foot? 3. So how many are in 2 yards? 6. So that changes to 6 feet. Can that be reduced? Yes, they can both be divided by 2. So 2 divided by 2 is 1 foot to 3 feet. On number 3, do we have the same units? Nope. So it's going to be easiest for us to change weeks into days. How many days are in 6 weeks?
42 days.
Very good. 42 days compared to 12 days. Can that be reduced? Yes, they can both be divided by 4. 42 divided by 4. I don't know that they can both be divided by 4.
How about 6?
6, yeah, I like 6 better. 42 divided by 6. 7 days compared to 2 days. Questions about simplifying ratios? Okay, then we will continue on. We've already done some practice with proportions today, so you can cross those ones off. And we will jump right into our notes. Oop, too far. In geometry, 2 figures that have the same shape are called similar. This is not to be confused when 2 figures are exactly the same. What did we call it when 2 figures were exactly the same? They were congruent. Exactly the same means they are congruent. Having the same shape means that they are similar. So they could be different sizes, but have the same shape. 2 polygons are similar polygons if corresponding angles are congruent and corresponding side lengths are proportional. So even if they're different sizes, the angles that correspond to each other still have to be exactly the same measure, but the side lengths just have to be proportional to each other. The symbol for similar is that little squiggly line. I think in Spanish class we called it a tilde. If you have 2 of them, like a squiggly equals sign, that's approximately. So if you just have 1, that means similar. Okay, so refer to your guided notes for the actual problem, and we'll just put the answers up there together. So on example 1, you've got the diagram. It says that JKLM is similar to, remember that's what that squiggly line means, WXYZ. JKLM is similar to WXYZ. This is actually extremely similar to what we were doing when we had congruent figures. So part A asks us to list all pairs of congruent angles. What do you think angle J is going to be congruent to, based on what we learned last semester? Angle W, it's going to work the same way, where they're going to match up in the similarity statement to the order they should go in. So angle J is congruent to angle W. Angle K is congruent to angle X. Angle L is congruent to angle Y. And angle M is congruent to angle Z. So we didn't even need to use the diagram for that because they gave us a similarity statement. Questions about corresponding angles being congruent? Okay. Part B says write the ratios of corresponding sides in a statement of proportionality. What that means is that we're going to write ratios for all of the pairs of corresponding sides and make one big proportion. How many pairs of sides are we going to have? 4, because each of those figures has 4 sides. So that means I'm going to have 4 ratios set up in a proportion. For this one, we will start with a side from JKLM. That'll go on the top. We will compare it to its corresponding side from WXYZ. That'll go on the bottom. You can either use the similarity statement, or what I prefer is to look at the diagram and use that. What is the longest side length from JKLM? Look at your diagram. The longest side length is KL, and it has a length of what? 16. We all see that in the diagram on our guided notes. Okay, the longest side length of your first figure should correspond to the longest side length from your second figure. So what is the longest side on the other one? XY, which has a length of 12. All right, so below this, I'll go ahead and write, so KL over XY was that first one. We'll do them both by names and by numbers, so that we've got all the information down there. What's the next longest side length from JKLM? JM. What does JM have a length of? 12. And the next longest for the other one is WZ, which has a length of 9. Are we all getting the hang of this? Okay, the next longest one. LM. Oop. LM has a length of 8, and we would compare that to YZ, which has a length of 6. And finally, we've got KJ, which has a length of 4, compared to XW, which has a length of 3. Okay, so when it asks for a proportionality statement, this is what it's looking for. One of these two things. If you're given just side length, like letters, you don't have the numbers, this is what they'll want down here. Okay, the other way would be if they give you the side lengths, here's another proportionality statement using the side lengths. Part C asks us to check that these are actually proportional. Okay, so one way to do that would be to go through and reduce all of the ratios. What do we notice that they are all going to reduce to? Not necessarily. Well, let's go through and do them one at a time. If we were to go through and reduce, so here I'll put part C over here in another color. If I were to reduce 16 over 12, okay, that reduces to 4 over 3. They're both divisible by 4. What about 12 over 9? What can 12 and 9 both be divided by? 3. 12 divided by 3 is? And 9 divided by 3 is? Okay, good. 8 over 6, they can both be divided by 2 to get 4/3. The last one already is 4/3. Okay, so if they all reduce to the same ratio, 4 over 3, then it would work. Sometimes you might have them to where they don't reduce quite that nicely. So you might have to use cross products, or we might look at somewhere the ratios, you just have to divide them out and show that it is the same ratio no matter what. All right, number 2 on your guided notes. We again are given 2 figures. We have to determine whether the quadrilaterals are similar. If they are, we need to write a similarity statement and find the scale factor of FGHE to ABCD. All right, so first we've got to see if they are similar. For them to be similar, that means that corresponding angles have to be congruent and corresponding sides have to be proportional. The congruent angles part shouldn't be terribly hard to check. Does every angle from ABCD correspond to an angle that's congruent to it in FGHE?
Yeah.
Yes, right? We can check those arc marks. Angle A and angle E both have 2 arc marks. Those are the same. Okay, C and H are the same, right? So the congruent angles are easy to check. So we could write them all out, but I'm okay on this one if we just say corresponding angles are congruent. Okay. So that's true. Corresponding angles are congruent. We checked that. The harder part to check is that corresponding sides are proportional. So kind of like we were doing before in that last problem, we've got to match up the corresponding sides and make sure that they are proportional to each other. Okay, so again, let's go with the longest side. Since they want to do FGHE to ABCD, let's start with FGHE. The longest side in FGHE is 20 compared to the longest side of ABCD, 28. Okay, let's just go down the line. So here's the first comparison. Let's make another one here. What's the second longest side from FGHE? 15 compared to 21. This one's a little bit trickier because they are not oriented the same way, right? So it takes us a little bit longer to identify which one's the longest, which one's the next longest. All right, let's keep on going down. We've got a couple more to set up. What's the next longest side? 10 would get compared to, what is it? 14. And then finally the shortest side of each. So we have FGHE first, 5 compared to 7. So these are the ratios of the corresponding sides. We just want to make sure that they are proportional. So let's go through and reduce them. 20 over 28, what can those both be divided by? 5, what would we get? Sorry, not 5, 4, which would give us 5 over 7. Next one, they can both be divided by 3, giving us 5 over 7. The next one, divide by 2, we get, can the last one be reduced? No, it just stays 5 over 7. So, are corresponding sides proportional? Yes, we got the same ratio every single time. Okay, so yes, they are similar. That was the first thing they wanted us to do. Then they wanted us to write a similarity statement comparing FGHE to ABCD. Now, FGHE, luckily they put them in order for us. That's not always going to happen. So our similarity statement would be that FGHE is similar to ABCD. Remember, when we do this, corresponding angles have to match up, right? So we have to go through and check to make sure, which it's already true though. H we can see is congruent to angle C. F is marked as congruent to angle A. Do we remember doing that with congruent triangles last semester? Having to make sure the order was correct. The last thing they ask us to do is identify the scale factor. Scale factor. If they want us to go from FGHE to ABCD, that means that FGHE has to be on the top, ABCD has to be on the bottom. That's why I set these ones up here like this. So that way our scale factor is just equal to this ratio that we got. The scale factor is the same as that constant ratio. 5/7. We did talk about scale factors a little bit when we did dilations. Remember when we took figures and made them bigger and smaller? So we have talked about scale factors a little bit before. On 3 and 4, that's weird, it's really 4 and 5 on your paper. That's strange. You can remark them on your paper as 3 and 4 instead. We are told that our two triangles are similar to each other. We are asked to find the value of x. Okay? These can be a little bit tricky because now we don't necessarily know which side is the longest, which side is the shortest, because one of the sides we don't know what it is at all. So we have to rely on that similarity statement. ABC is similar to XYZ. So before we even start solving these or setting them up, I want to write a proportionality statement just based on the sides with their letters, not the numbers. Okay? So this will be similar to what we did when we talked about congruent triangles. So for example, I'm going to compare AB to what side from our other triangle? XY. And I'm going to compare BC to what side? YZ. And I would compare AC to what side? XZ. Okay, are we all okay with how I set that up? So I didn't even use the diagrams they gave me, I just used the similarity statement. Now we can use this on both problems because we have the same similarity statement for both problems. So for number 3, what is the side length of AB? 15 compared to what is XY? 9. Equals, what's BC? x, right? They labeled that one x. And we would compare that to yz, which is, what's yz? 6. If you wanted to, we could continue this on and fill in AC. What's AC? 20. And XZ is 12. Okay, but we don't need to do that. We just need one proportion where we have the variable that we need to find. So it doesn't matter to me if you're going to use the first half of this problem that we set up, or if you want to use the second half of it. We just need a proportion that we can solve. Does that make sense? So we don't necessarily need all 3 pieces. We just need 2 of them, and one of those pieces has to include our variable. So if I'm sticking with the first half of this, or the first 2/3 of it rather, and I cross multiply, what do I get? 90 equals 9x. This is why we did proportions yesterday. How are we going to solve? Divide both sides by 9, and we get x equals 10. Questions about number 3? Okay, let's go to the next one. Again, we can use the same proportionality statement that we made here. So what is AB? 3 compared to XY equals, what is BC? Again, it's X, and YZ is 10. So we don't have to set up the last proportion. We don't need AC over XZ. We can solve it right here. What are we going to do? Cross multiply. 10 times 3 is 30 equals 6 times X is, and then what do we do to both sides? Divide by 6, we get X equals 5. Questions about this? Okay, one thing I want to point out real quick before we get our homework, that it's not necessarily clearly stated in the notes. This right here is called a similarity statement. So if you are asked on your homework for a similarity statement, you need to write something that looks like this, that's got the squiggly line in between it, right? This is a similarity statement. This next part down here in the red is a proportionality statement. So if you are asked on your homework, or say a homework quiz next week for a proportionality statement, you need to have corresponding sides written as ratios set up in proportions. Does that make sense? Do we see the difference here? We have to know the difference between a proportionality statement and a similarity statement.